Welcome back to geometry. We're in section 3.5, the polygon angle sum theorem. Now, before we start, let's recall that we had a theorem in the last section which said that in all triangles there's going to be 180 degrees. And so this was called our triangle sum theorem. And it's interesting to note that this section is called the polygon angle sum theorem. So it looks like we're going to be coming up with a rule that will determine the sum of the interior angles of a polygon. Now, we're not there yet, but that's just something to note and to keep track of. These definitions are reviewed from Unit 1. Remember that on a convex polygon, all its diagonals are in the interior, so that would look like the drawing that we have down below. These are going to be convex, and they are also called polygons. And the reason being is that when you draw these diagonals, they intersect inside your shape. And so that's what a convex polygon is. Same thing as these diagonals. So remember that a concave would look sort of just like Pac-Man or a cave. And so it caves in. Okay, so that would be a concave polygon. Alright, next, to draw a shape that is a polygon, well, there's many polygons. We can draw our triangle, we can draw a square or a rectangle, we can draw a pentagon, 5 sides, we can draw a hexagon. Whoops. And so these would be ones that are polygons. So we'll say yes, and then ones that are not. That would be our circle, okay? Because a polygon has to be a closed figure made of line segments. And so this is not line segments that are formed here on a circle. These are line segments. All right, one of the things that's important here is that we have this new term called regular polygon, and that's a big term. So for a regular polygon, it says that all sides and all angles are the same. So let's draw an equilateral triangle. We'll show all sides and all angles are each congruent. And in a triangle, that means each interior angle is going to be 60 degrees. These are all 60-degree angles. We can draw a square where all sides and all angles are each congruent. And in a square, that would give us 90-degree angles all the way around. Next, we can draw a pentagon. That is a regular pentagon. And that's kind of a bad drawing, but all sides are the same, and all angles inside are also the same. We can also draw a hexagon, 6 sides. And all sides are each congruent, and all angles inside are also each congruent. Alright, so these are the regular polygons. When we name a polygon, we name it by its vertices. Now recall that vertices is another name for angles. So once you select a vertex or an angle of that polygon, the rules are strict. We can either go clockwise or counterclockwise. Meaning, let's start at A, and I can call this polygon A, and then if I go clockwise, it'll go B, C, D, E, and that's acceptable. Or I can start with A and go counterclockwise, the other way around. So A, E, D, C, B. I could also start at some random point like D. And once I start with a point, I then have to go in order. Okay, and again, I can either go clockwise or counterclockwise. So I guess let's go counterclockwise. So I get D, E, A, and we'll define what it is down here. So just kind of ignore this first theorem, or just draw an arrow down to the name of this theorem. So first, we're told to select a vertex from each polygon and draw all diagonals from that vertex. So let's start with this angle, or this vertex. We're going to draw all diagonals from this angle. So we have one diagonal and a second diagonal. And that's it. I can't draw any other diagonal. Now hopefully what you see here is that we have formed three triangles, right? Here's one triangle that would add up to 180 degrees. Second triangle, 180 degrees, and a third triangle, 180 degrees. So we're being asked to solve for n and triangles. Now n stands for number of sides. So we have 1, 2, 3, 4, 5 sides, and we have 3 triangles. And what's interesting to note is if I add up all 3 of these triangles, I'm going to get 540 degrees for this shape. Now this shape is called a pentagon, and recall that penta means 5, so it's our 5-sided polygon shape. Alright? Alright, then we're going to look for a pattern, because the next shape we have is a 4-sided shape. So we're going to put 4 sides, or 4 number of sides. We're going to draw from this vertex. There's only one diagonal. It goes to here. And hopefully now you can see that we have created 2 triangles. 180 degrees for this triangle, 180 degrees for this triangle. Now this shape is called a quadrilateral. Quadrilateral. And even more specifically, this is called a trapezoid. And think of the word quad means 4. That makes sense because we have 4 sides. We also created 2 triangles. And since we created 2 triangles, the sum of the interior angles of a quadrilateral is going to be 360 degrees. Alright, right about now, let's flash back because we have our triangle sum theorem, which says that the measure of all interior angles, INT, of a triangle is going to equal 180 degrees. And so we just found that all pentagons will have 540 degrees as the measure of all interior angles, and a quadrilateral is going to have 360. And so hopefully you can see what's happening here, or follow that pattern. From this angle, we're going to draw this diagonal, we're going to draw this diagonal, we're going to draw this diagonal. So let's start with number of sides. We have 1, 2, 3, 4, 5, 6. Number of triangles. We have 180 degrees in this triangle, 180 degrees in this triangle, 180 in this triangle, 180 in this triangle. We have 4 triangles. Now all 6-sided shapes are going to be called hexagons, and hex means 6. And since we have 4 triangles, we multiply that by 180, and we get 723. So following this pattern, it looks like, here we have 5 sides and 3 triangles, 4 sides and 2 triangles, 6 sides and 4 triangles. There's always a difference of 2. So that's why the sum of the measures of the interior angles is going to be 180 degrees times n minus 2. And so this works for all polygons. The sum of the measure of the interior angles of all polygons is 180 times n minus 2, and where n equals number of sides of a polygon. Alright, so we come to a quadrilateral shape. We know there's 360 degrees total. Therefore, I can add all these angles up. We get 130, we have 114, I add these up, I get 270. 360 minus 270, and I can't tell if this is 28 or 26. I'm going to stick with 26 degrees, but I could be off. Who knows? This is going to be a 90-degree angle for angle A. And how did I get that? I took 360 minus 270. Next shape. Again, I always think it's smart to write the total angles, that all of these angles will add up inside, just like I did with this shape. So this is a pentagon because we have 5 sides. So I'm going to put 540 degrees. And how did I get that? Well, I took 5 minus 2 times 180 degrees, which is our theorem that we just learned up here, which is called our Polygon sum theorem. So that's going to give me 180 times 3, which is giving me 540 degrees. All right, then let's enter in what we're given. We're given that angle H is 135. We know these boxes are going to be 90 and 90. We know angle E is going to, we're told that it's 90. So the unknown is going to be angle S, but we just put S. We don't know what angle S is going to be. So we add all these up. We have 135, we have 180, and we have 90. We get 520 carried to 2, 405. We take 540 minus 405, and that gives us 135 degrees. So angle S, or X, is going to be 135 degrees. Alright, next shape we have is a quadrilateral, 4 sides. So I'm going to write quadrilateral. And I always like to put what the measure of all interior angles will be for each shape, 360 degrees. Now these little marks right here, this means that angle Y and angle X are congruent. Angle Y is equal to angle X by these little marks. So let's put an X and an X for an unknown. So we add up all the angles, X plus our 90-degree box plus 100 is going to equal 360. 2X plus 190 equals 360. 2x equals 170, x is going to equal 85 degrees. Alright, down below it says mark each figure to show the polygon is a regular polygon. So we're going to put all sides are congruent. All angles are also each congruent. Alright, next let's find the measure of each interior angle. Well, we have 360 degrees total. So that means all of these angles, since they're the same, if we take 360 divided by 4, that means each angle has to be 90 degrees. So 90 degrees, 90, 90, and 90. Alright, next ask for each exterior angle. So that's a little bit different. We're going to extend out this angle and create an exterior angle, like so. Let's call this angle 1. And hopefully you can tell this forms a linear pair. So if this angle is 90, angle 1 is also going to be 90 degrees. Now we have to find the measure of each interior and each exterior angle. So we have to do this a few more times. So let's extend out this line. This is also going to be a 90 degree. And I'm going to put EXT for exterior angles to remind us. And then we extend out this line 90 degrees. We extend out this line 90 degrees. So to summarize, we have interior angles each equal 90 degrees, and the exterior angles were also equal to 90 degrees. And just like we did on the last theorem, we're going to see if we can find a pattern here. Next shape is a pentagon. We have 540 degrees total. All sides and all angles are each congruent. Now again, this is a regular polygon. Okay, so the only reason why we're allowed to make these marks is that we're told, it's given to us that these polygons are in fact regular. So all angles are the same. We'll put a single mark showing all angles are the same. Well, if we have 540 degrees and we have 5 angles, that's going to be each angle is 180 degrees. Now, that should make sense because when I look at all of these internal angles, they look to be obtuse. So it would make sense that all these angles are 180 degrees. We can go all the way around. 108, hexagon is going to equal 108 degrees. Next, we're going to do the same for the exterior angles. So we extend it out. It forms a linear pair. 72 degrees. 72 degrees. 108, 72 degrees. 72 degrees, and 72 degrees. So each exterior angle is going to equal 72 degrees. Alright, then last, but certainly not least, are hexagons. So all sides, all angles are congruent. And in a regular hexagon, we have a total of 720 degrees. How did I get that? Well, we use our formula. It said 180 times n minus 2. So 180 times 6 minus 2, 180 times 4, 720 degrees total. Next, to find the measure of each interior angle, we're then going to divide this amount by the angles we have. We have 6 angles that are all the same. So we end up getting 120 degrees. And that should make sense because if we look at each interior angle, it looks up too. So it looks to be about 120 degrees. So we have 120 all the way around. So let's write this down. Each interior angle is going to equal 120 degrees. Alright, well we want to do the same for the exterior angles. We're going to extend all these out. 120 and 60 degrees, that would form a linear pair. 120 and 60. 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 And so each exterior angle was 60 degrees. Alright, next, we're being asked to find the sum of each, or the sum of the exterior angles for our square. So each exterior angle is 90. We have 4 of these angles, so 90 times 4 would give us 360 degrees. Next, the sum of all exterior angles. We have 5 exterior angles. They measure 72. So 72 times 5 would give me 360 degrees. Last, we have our hexagon. We have 60-degree angles. We have 6 of those angles, so 60 times 6 would give me 360 degrees. So again, we're being asked to find the sum of the exterior angles. Inside, you were asked to find the sum of the interior. So here's the sum of the interior was 360, 540, and 720. Those are the sum of the interior angles. It's interesting to note that for all these shapes, the sum of the exterior angles was always 360. So that leads us to our next theorem. It's called the exterior angle sum theorem. The sum of the measures of the exterior angles of a polygon is always going to be 360 degrees. Last problem. They want us to consider a regular octagon. So let's draw out an octagon just to get a visual. And an octagon is going to have 8 sides. It looks like our stop sign. And the key word here is regular. So all sides and all angles are each congruent. And all the angles are also going to be each congruent. Alright, so they want us to find the sum of the exterior angles. So remember that the exterior angles will form a linear pair with the interior angles, so we extend all these out. And so these, we have to find the sum of all of these angles. Well, if we think about that last page, we just had a theorem that said the sum of the exterior angles of all regular polygons is always going to be 360 degrees. So this is from our theorem. And it was our exterior angle theorem, which says the sum of all exterior angles is 360 degrees. Now, if you forget this, it's okay because we can still do all the work and then get 360. So we should probably first start with the sum of the interior angles. So since we have an 8-sided shape, we're going to use our Polygon sum theorem. just like we have a triangle sum theorem, we have a polygon sum theorem. So it's 180 degrees times n minus 2. Well, in this case we have 8 sides. 180 times 6 is going to be 1080. So the sum to measure the interior angle is going to be 1080 degrees. Let's go to the measure of each interior first. So we take 1080 and we divide that by 8 because we have 8 sides and we have 8 angles. So since all the angles are the same, we can divide 1080 by 8. Let's do some longhand division here. This is going to give me 1, 28, 3, 24, 135. So each angle on the inside is going to be 135 degrees. That makes sense. All these angles are obtuse. 135 degrees. And then they're asking for the measure of each exterior angle. Well, again, it forms a linear pair. So since we have 135 here, I can put 45 degrees on the outside. And so I have 45 degrees. So we're being asked, what should always be true about the relationship between the measure of an interior angle and an exterior angle? Well, the relationship will always form a linear pair, which means that the interior and exterior angles, they'll always add up to 180 degrees because they are supplementary. Thanks for joining us. See you next time.